Hi everyone. So in this video I'm going to show you how to deconvolute an XPS spectra and then plot it in Origin. The software which I'm going to use to deconvolute is called XPS Peak 4.1 and it is a free software. When you go to the browser and type XPS Peak, you could see this website. Just click it. Once you open that, you could see, go to this XPS Peak and the corresponding file. When you click it, it will just go to the downloading page. Then once you download it, just unzip it and then run the setup. You can easily install it. I'm not going to do it again, so let's go to deconvolute. So this is a software. Once I double click it, you see two windows are opening. Okay, so I have the entire spectrum, and the one which I'm interested is the nickel 2p peaks. So I have the binding energy and the corresponding intensity values. I just copy the data. Then in order to import this, I actually have to have an ASCII file. So I just open a new text document, then rename it as ni2p. I will open it, then I will paste it. So you see we have the binding energy and corresponding intensity values. I will save this file. So you can also see how it looks when I plot it in Origin. Okay, so if I just import it, you see this has 4 peak. It is corresponding to nickel 2p. So let me import it here. So I will import ASCII. I will go and select this file which we just made, open it, and you see this is the same peak which we had got. First, in order to deconvolute, we have to define a background. Just click that background button here and then select which type of background you want. I'm selecting Shirley type of background and then I will accept it. You see this background is formed. You can modify the background by changing these parameters. Now we have to start adding the peaks. For that, we add peak here. Once we do it, we see a peak here, so we have to bring this peak and add different peaks to different locations. So this is the corresponding XY value of our pointer. So we just look where this location is. It's like 856.47. we type here 856.47, then fix, then uncheck this one, accept it. You see the peak has moved to that position. Now we will do the same procedure for all the other 3 peaks. Yeah, we have added all the 4 peaks. Now when we add this peak, we will see corresponding new columns formed in the second window. We can just go through and see all the peaks here. So now what we are going to do is, like, we will select each of these peaks and then we will uncheck this fix button, then save that. Next, we have unchecked the fix position. Now we will go and click optimize all. You see these waves are getting modified to match with our original value. Now we will click this optimize all multiple times so that the chi-square error is getting decreased. So after a certain number of times, you see this number gets saturates. Yeah, it has reached its minimum value. Now we can go to this window, then export our data. Export spectrum. It will make a new file. We will rename it as ni2p fit, then save. This is in .dat format, so just save it. Okay, so this is the file. We will open it in Notepad. See, This is the binding energy and corresponding intensity of the deconvoluted peaks. The last peak is the difference with the original, which we don't need to plot. But anyway, we will just select all, then copy it, and now we will paste it in origin. We'll open a new sheet. Yeah. So this is the X and Y. When we click plot, you see we have the original plot along with the deconvoluted peaks. You can modify the X-Y axis to make it more aesthetically pleasing and also of publication quality. So I have already made a template which I use for my papers. So this is the template. You see, I have added the value of X for different peak location and the oxidation state. These are not actually true here, but this is a template. So yeah, I have to delete this and add the corresponding values. Yeah, now we have this peak. Now we have to look at where the intensity max is coming and check the values of the binding energy corresponding to which oxidation state or which bond we are focusing on with the literature. And you can use a lot of database. One is the XPS database, this one, and the other one is the Thermo Fisher's XPS. So if I go and click the nickel one, you have the one here. This looks almost similar to our plot, right? So we have to see which piece corresponding to which one. And also you can refer a lot of literature so that you can pinpoint which bonds correspond or which peaks correspond to a type of bond or like oxidation state. So that is it for today's video. Thank you. See you next time.